get started now. So we're making good progress. We've just finished trigonometry chapter, believe it or not. So now we're on to the calculus chapter, and we're going to have a look at something called first principles. Okay. So here's the concept behind this lesson. If I want to find the slope of this line, I need to have 2 points on it, right? But suppose I don't have a line, suppose I have a curve and I want to get the slope. Well, it doesn't quite mean the same thing, because if I get 2 points here, well, that's a different answer if I took 2 points, say, there, isn't it? Yeah. Getting cold? Yeah. So, the only way we can meaningfully have a slope here is at a particular location. So, suppose I was to say, okay, what's the slope here? What we could do is draw a tangent line. That's what we could do. But we have a little bit of a problem. If I want the slope of this line, how many points do I need? No, I need. If I want a line, I need. Should really have 2 points. But the problem is, the second point, I have no idea where it is. I mean, I can know where this is. You know, if I tell you that this is 1, I can know exactly where this is. But I have no idea where to put the other point. You know, it's not clear where it goes. So there is a way around this. If I zoom in, I can show you. So let's how can I imagine zooming in? Okay, so here's the graph. Let's imagine I zoom in on this piece. Okay, so if I zoom in, it would look something like that, if I zoom in real close. If I take 1 point here and 1 point really close to it, do I have a tangent? Technically, no. Technically, no. Because what does it mean to have a tangent?
Crossing through 1 point.
Crossing through 1 point. Whereas here, I crossed through 2 points. So is it a tangent? No. But if these points were very close together, it would kind of look like a tangent, wouldn't it? Mm-hmm. Like, let's imagine I zoom back out now. So if I zoom back out, my 2 points are so close together, it nearly looks like a tangent, doesn't it? It's not perfectly a tangent, but it nearly looks like it. So this is the concept behind this lesson. What we're going to do is we're going to get the slope of, not quite the tangent. What is this called if it's not quite the tangent? If it crosses twice instead of once? Does anyone know its name? The almost tangent? The near tangent? The half tangent? What could it be? C. Yes, good, yeah. The slope of the chord. Which is going to be nearly the slope of the tangent. We'll make the 2 points close together. Okay? And the symbol for the slope of the chord, does anyone know? It's this here. Delta y over delta x. Let's take an example. Let's do our first example. Let's take something not too difficult. Let's say I have y equals x squared. And I would like the chord, which is nearly like the tangent at the point, let's choose 2. So I want to draw a tangent here. Can I draw a tangent perfectly? No, I'll draw a chord. So I need a second point. Okay. What will we call its neighbour? Well, if this guy here is 2, we want this number to be nearly 2. So what could we use? Could use something like 2.01? Yeah. In other words, we should use 2 plus a tiny little number, I'll call it h. Okay? So, let's write down our 2 points. Here's our first point, and here's our second point. Our first point, the x is 2. Here it is here. And what's the y?
X squared.
Yeah, so, yes. Our second point, which is here, which will go up there, what's the x? 2 plus h. And the y? 2 plus h squared. Now, we have 2 points, so is it possible to find the slope? Of course. So the slope will equal y2 minus y1, yeah, over x2 minus x1. That will be 4 plus 4h plus h squared minus 4 over h, which will be h squared plus 4h over h, which will be h plus 4. We normally put the h at the back. 4 plus h. So that's the answer. That's the slope of the chord. If you want it to be very accurate, then the value of h should be very small. Okay, so for example, if you use h equals 0.01, then the chord would have a slope of 4.01. Now, what you'll notice about these questions is, rather than doing it this way, you can actually jump straight into using what's called the first principles formula. So let's just keep it a bit more general now before I continue on. So let's imagine I have 2 points. The first point is x, and this y value would be fx. Okay, and then the neighbouring point, what will we call that? It will be x plus h and fx plus h. And what would be the formula for the chord? It would be fx plus h minus fx over x plus h minus x, which leaves me with just h then, isn't it? Which you actually saw, that's what happened when I did the example. So we can use this formula just directly without thinking about anything. But I wanted to show you what we're really doing. But in the exam, you wouldn't do it like this. You would just directly use this formula. Okay? So in a moment, we'll do another example where we just directly use this formula. But if you can write this down, please.
Yeah, I like the way you always show the roots of each formula. It's like no math teacher do it.
It's good to know why you're doing what you're doing. Or at least where it came from.
Is that x plus 4 or x plus 8?
Oh, where?
This one.
X plus here? Here?
No, no.
Here?
This one. Is it plus 8?
Oh, sorry, here, up here. X plus h. Yeah. Yeah. We'll have a look at another example just using the formula directly. scroll down?
A second.
No? I'll just help you out by fitting this in a bit more. Okay? Okay. I think this is one of these topics that not everyone has studied before, calculus. I mean, maybe most of you have, but it's not a topic like trigonometry where I would expect everybody to have. Who has not studied calculus before? No? Everybody? Oh, you haven't yet? Okay.
Calculus is like differentiation.
Yeah. Yeah. This topic. Okay. I'm going to scroll down now. So, let's do another example. Let's say we have, I don't know, a graph like this. Y equals minus x squared plus x. I think that would be a shape like this. Let me confirm it. Oh no, my program's closed. That's right, isn't it? No. Yes. Yes, that's right. Yeah. Okay. So the question might be, find the slope of the chord, the almost tangent. Usually, we don't specify where. So do you notice in the last example I gave you a particular point. I said x is, what was it, 2, wasn't it? Yeah. What is much more common is you just keep the point general. You just call it x, generic x. And you want the slope of the chord roughly at x. But we do everything the same. We just don't put in a number. Okay. Right, so let's use our formula. It's fx plus h minus fx over h. Oh, the reason we keep this as x usually is because it means it gives the person the option of picking the x at the end. When they get the answer, they can choose the x that they may want to use. So, let's see. Here's our function. So that would be minus x plus h squared plus x plus h. So what I've done is I replaced x with x plus h. Is that okay? Yeah. And then minus fx, which is minus this. So minus x squared plus x, all over h. Now just to be clear, this guy is that guy, but I replaced the x with x plus h. And this guy is that guy, but I just kept it as x. Can you see x replaced with x plus h? Yeah? And here I just kept the x as x? No.
Not really.
Really? Interesting. Okay. This is x. Agreed. I replace x with x plus h and I have this.
Why?
No, of course.
Here, I'm replacing x with x plus h.
fx equals
This is fx.
When you use color services, so to be clear.
Yeah?
yes.
Oh, excuse me. I thought it was obvious. Okay, fine. fx. Okay, equals. Right, better? And then I replace this x with x plus h.
Why?
That's in the formula. I'm using x plus h. Yeah. Why what? Colours, they're so amazingly useful, aren't they? Is that okay? Yeah? Right. Let me remove my... Okay, no, I'll leave the colours there. Okay, let me simplify the top. So I'll expand this. What do I get? Minus x squared minus 2xh minus h squared plus x plus h plus x squared minus x all over h. Right, what am I left with on the top if I clean this up a little bit? This fella cancels with that fella. This one cancels with that one. So what am I left with? Minus 2xh minus h squared plus h all over h. Let's divide everything by the h. Minus 2x minus h plus 1, or just minus 2x plus 1 minus h. Now, this is really nice because you've not specified the x. This means the person can choose the x. So you could say, what is the slope of the chord here when x is 0? What answer would you get? You would get 1 minus h. Or I could say, what's the slope of the chord here when x is 1? What would you get? Minus 1 minus h. You see? So it's more normal to specify the x at the end. So what you normally see is something like this. The person would then write a line here saying, okay, now I want to make, for example, x equals 0. So then you sub 0 in and you would get 1 minus h as an example. Okay, this is more normal. So if you ever see a question where they put a line here and write x equals 2, what they're saying is, please do this with x, and then at the end, put the x in. Okay? Now, the next idea continues from this idea. So I'll use this example leading into the next one. Is this a tangent line? Yes or no? Is this the slope of a tangent?
No.
Technically, no. Why not? Yeah. It cuts twice. Okay. What is the distance between the 2 points? How far apart are the 2 points? H. Okay. If I make the h smaller, would you agree that the chord is becoming more like a tangent?
Yes.
Yeah, it is. It's becoming more like a tangent. It's not becoming worse. It's becoming better. So I should make the h smaller and smaller. In fact, what would happen if I make the h become 0? What would my chord become? It would become the tangent, wouldn't it? So, if you want to make this the actual tangent, at this final step, all you need to do is cause the h to vanish to 0. And what are we left with? Minus 2x plus 1. And now this is no longer the slope of the chord, but it's precisely the slope of the tangent. And we don't use delta y, delta x to represent this. Instead, we use dy dx. Okay. Yes?
Okay.
Yes? So dy dx is the slope of the tangent. So dy dx is delta y, delta x, except at the very end you consider the limit as h going to 0. So, some of you have seen this symbol before. Derivative, yeah. Yeah, I would have perhaps thought so. Straight away you were just told about this. Okay? But I want you to see where it came from. Okay? It's a limit of the chord becoming a tangent. Right? So if it's a chord, it's this. When it becomes the actual tangent, it's this. And the only difference between the two is the h. The h has to become 0. Yeah, yeah. How far? More? Less?
Yeah.
This enough?
No, more.
More, okay.
Yes.
Can you see it all? Yeah. Now, some of you might be... No, sorry. Some of you are wise guys, and you think that, oh, Mr. Stephen, why am I doing all this work when I know a quick way to get the answer here? Right? Yeah, see, some of you are wise guys, yeah. So, I'm sorry, in the exam, it has said, calculate dy dx using first principles, which means you must do it this way. Yeah.
I hope they will watch this video.
You don't, I'm sorry, you can't use the rules that you would have learnt before to quickly get the answer. If the question says to use first principles, first principles means this rule here.
How often is it like first principle?
50-50. If you feel lucky, you can take a chance. Yeah, yeah. 1 sec, sorry, yeah. Next to this here? Yeah.
Why is it negative?
Here?
Yeah.
Oh, because, sorry, maybe you can't see. In the rule, it's a minus here. Fx plus h minus fx.
Okay.
Question, yeah? I changed your mind?
No, I'm just thinking.
Yeah?
Is it always over H?
Yep.
Okay.
This is the first principles rule.
So this is always the first principle.
Over h, yeah. Yeah. Anything else? Yeah?
At the end of the when you look at the H0,
Mhm.
you have to solve it out first before you look at H0.
It happens at the end.
Okay,
Yeah.
so you can't stop it.
No.
Okay.
No. Because you first need to arrive at the formula for the chord, and then you imagine the chord transforms into a tangent. You can't put the h0 at the beginning, because the premise at the beginning is you need 2 points. And if you are starting by making h0, you kind of broke that premise by having only 1 point. So it needs to happen at the end.
Teacher,
Yeah.
I'm confused why from negative x squared plus x, how did you get negative x?
Negative x squared plus x at the end here.
So like the whole thing, I don't understand how do you get that whole
Oh, really?
thing. Yeah.
Interesting. Okay. Fx equals minus x squared plus x.
Yes.
Fx plus h, what does that equal? Minus x plus h squared plus x plus h.
Plus because of the two negatives.
Uh,
The negative
no.
x.
Color time. Look. Fx is minus x squared plus x.
Yes.
Fx plus h is minus x plus h squared plus x plus h. The x plus h has the role of being like the x in the original formula. Yeah, okay. Alright, I need you trying some of these now for a few minutes. I think what would be suitable for the exam is question number 2. Do all of question 2. Yes.
We put like positive because of the negative. Of the
No.
negative.
Oh, yeah, correct. Yeah, I can think about it like this, yeah. Yeah. The last lesson. Yeah. Can I just close this? Yes. I'll come down to you.